Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 1, Section 4, titled Integers and Absolute Value. By the end of this video, you will have reviewed the procedures for comparing integers, plus you'll have reviewed finding absolute values. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get to it. So before we get started, I'd like to go over a couple definitions. Opposites. Numbers that are the same distance from zero on the number line, but in opposite directions, are called opposites. Integers. Integers are whole numbers and their opposites. Absolute value. A number's distance from zero on the number line is called its absolute value. For example, you write the absolute value of 3 as these two pipes with a 3 in the middle, though that's called the absolute value sign. Okay? Objective 1, comparing integers. Here's a little story for us to go through. Antifreeze is mixed with water in a car's radiator to prevent the water from freezing. Pure water freezes at about 32 degrees Fahrenheit. That's, as you see the symbol for it, degrees Fahrenheit, above zero. A mixture of equal parts water and antifreeze freezes at about 32 degrees below zero. You can write 32 degrees above zero as plus 32 degrees F, or 32 degrees F. You can leave the plus sign off. Or you can write 32 degrees below zero as minus 32 degrees F or Fahrenheit. Read the numbers 32 and minus 32 as positive 32 and negative 32, respectively. So let's look at this chart. We have some freezing points, the substance and the freezing temperature. Water, as it shows you right here, water freezes at 32 degrees, and we all pretty much know that. Antifreeze and water, that one-to-one mixture, freezes at negative 32 degrees. Seawater freezes at 28 degrees Fahrenheit. And gasoline, I've never thought of this, but gasoline freezes at negative 36 degrees. Okay, example 1, representing negative numbers. Temperature. Write a temperature to represent the temperature shown on the thermometer. Well, let's look at this. So we see a negative 5, or the 5 way at the bottom, negative 5 degrees Celsius, 5 degrees Celsius towards the top. And then in the middle there, between the two, we have 0 degrees Celsius, that little tick mark. The little tick mark is right here. This tick mark right there is 0. They want us to write the temperature represented by I'm guessing the intersection of the red and blue area. And that intersection is right here. And what is that temperature? Well, that temperature is negative 4 degrees C. You see, you go to 0 and go 1, 2, 3, 4 down, right there, 4 down, negative 4. It went from 0 down, in this case, it's going negative. If the red line was up here higher above the 0, up in this area perhaps, it would have been 1, 2, 3, maybe 4 above 0, or positive. Below the 0 is negative, okay? So the temperature of the liquid in the thermometer is at negative 4 degrees. Okay, example 1, check your understanding. The directions are write the number. Okay. Temperature. Seawater freezes at about 28 degrees F. 28 degrees Fahrenheit. About 2 degrees Celsius below zero. Okay. Write a number to represent the Celsius temperature. Well, what is if it says 2 degrees Celsius below zero and they want us to write the number, what are we going to write? Well, we can start with 2. 2's in here, but they want it below zero, so that means it's going to be -2 because we start at 0 and go down to -1, -2, -3, below the 0. Okay? So writing the number represents the Celsius temperature. -2, and we can add this, Celsius, but the -2 would suffice here. Example 2, graphing on a number line. This line here with all the tick marks on it, right here, this line, that's a number line. So it's a line with hash marks and numbers from 0 up or 0 down. You can really start these numbers wherever you would like, but generally number lines start at 0 and work from there. At least in our situation, it's going to be that way. And what they're saying is please graph -1, 4, all right, -1, 4, and -5 on a number line. We've given the number line. And order the numbers from least to greatest. Well, if they're on the number line and you graph them, they're going to automatically be from least to greatest, from the left to the right. But let's go ahead and do that. If we do that, we're going to say we want red. Let's mark it on the line. The red for -5, right here, -5. 5 units below, 1, so 1, 2, I'll do it, 1, 2, 3, 4, 5 units below 0 is this point right here. That's -5 on the number line. Then they want -1 on the number line. Well, that's easy. We start at 0 and we go 1 to the left. We're now -1 on the number line. And we could say that this is now graphed. We've graphed the point -1 on the number line. Okay? Then the next one says 4 on the number line. Well, to do 4 on the number line, I'm going to change colors. We're going to do that one in blue, as it's asking here. And as you see, it's way up here. 0 starts down here. 1, 2, 3, 4 in the positive direction above the number line, right above 0, right here. 4 on the number line to the right of 0, okay, is our 4 units. So for example 2 under check your understanding, they have one problem. Graph 0, 2, and -6 on the number line. Order the numbers from least to greatest. Well, the negative numbers are least, and the bigger the negative number, the more least it is. How's that? The smaller the numbers, or farther it is from 0. Can't think of smaller, but it's farther from 0 for sure. And we've got 3 numbers we're going to find. We're going to find 0, 2, and 6. Well, first of all, I can tell you that 2 is, we're going to go on the number line, and here 0 is right here on the number line, right there. That's 0. So we've now, if we put a circle there, if you want, we could put a circle. We've now graphed the number 0 on the number line. Next, they want us to graph the number 2 on the number line. Well, the number 2 is right here. We're going to graph number 2 right there. We're going to put a dot right there, and that is 2 on the number line. And -6 on a number line. At -6, we're at 0, -1, we're going here. -1, 2, 3, 4, 5, 6. -6 right here on the number line. We have now graphed these 3 in order from least to greatest. -6 is the least, 2 is the greatest. 0 is between them. So the outer numbers are either greater than or less than the number 0. That's an important concept, that 0 is less than the number 2 and it's greater than the number -6. It's to the right of the -6 and it's to the left of the +2. Objective 2, finding absolute value. So it says here that numbers that are the same distance from 0 on a number line, but in opposite directions, are called opposites. We talked about that once before, earlier up in the definitions. They're opposites. It's like the same number, but they're going in the opposite direction. So they're the same size, a 4 in this case, a -4 over here, and +4 on this side. They're opposites each other. One is 4 units above, 1, 2, 3, 4 units above. The other is 1, 2, 3, 4 units below. So the number is 4, but they're opposites. One is -4. This is -4, and the +4 is up here. But they both carry a 4 as their size. Okay? And notice too, the pipes, we call them pipes on the keyboard, right? So negative, I'm going to do it, -4, with that line like that. The line, the number, and a line. These vertical lines. Those are called the absolute value. That is the togetherness of that, the jointness of that, all one unit. It's called the absolute value. And the -4 inside, you would say the absolute value of -4 is equal to 4. The absolute value of -4 says, how many units is this from 0? Oh, it's 4 units. That's the absolute value. That's 4 units. And on the positive side over here, 4 units from 0, the absolute value of 4. Here was -4 down here on this side. On this side, it's a +4. The absolute value of 4 is equal to 4. It's the number of units from 0. -4 is 4 units from 0 in the leftward direction, or the negative direction, and +4, the absolute value of 4 is 4 units from 0 in the positive direction. They're both the same units from 0. Their absolute value. Okay? Okay, let's do one example 3, checking our understanding. Directions. Write the absolute value of 10 in words. Okay? And then find the value of absolute value of -10. Well, in words, writing this, we would say the absolute 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 value value of -10 of -10 is 10. It says find the value of absolute value of -10. The absolute value of a -10 is equal to 10. I wrote it out in words, and here it is. To think of it, -10, the absolute value is 10. If you put a 10 in here, the absolute value of 10 is still 10. You're 10 units away from 0.